welcome. So today we're going to talk about silicon as an ATR crystal. Now silicon has a nice property, and that's its pH tolerance. It can accept samples from a pH of 1 all the way up to 12. So what do we have to think about when we're choosing silicon as a crystal? Well, one that we want to target today is the spectral range. Now that's going to depend on the beam path length through that crystal, because there's some silicon phonon bands in that fingerprint region. So the longer the path length through the crystal, the less spectral range we're going to be able to get. So let's start off by looking at some of those ranges. Now the first one would be a micro machined silicon wafer. Now we use this wafer on the Pike automated auto ATR, and we also use it for the VMAX for electrochemistry experiments. Now this wafer is only about a millimeter thick, so we have a wide path length, and you can get data all the way down to 500 wave number. Now what happens when the crystal dimensions change and we have a longer path length through that ATR crystal? So now let's look at a VMAX silicon crystal. Now the VMAX uses a 20 millimeter prism. Now you can see we're cutting down the range of that crystal because now we have those silicon phonon bands starting to absorb more. Now let's take one more step up and look at the Pike HATR multiple reflection silicon crystal. Now that crystal is 80 millimeters long, and the beam's going to go into the crystal and bounce all the way down the crystal, reflecting at the sample side and the bottom side of the crystal 20 times. So the path length's pretty long. Now you can see we're really reducing that range because those phonon bands are super absorbing, and now we only have a range from about 1500 wave number. So what does that mean for your analysis? Well, if you're looking for some absorbance bands between about 1500 and 400, well, you're not going to be able to see them, and you need to look at some alternative ATR crystals. So there's your tip. When you're using silicon, be thinking about what that spectral range is of that silicon crystal, and be sure it's right for your application. So thanks for watching, and we'll see you next time.